The last Tasmanian tiger died alone in a zoo on September 7, 1936. Its name was Benjamin. The zookeepers found it curled in the corner of its concrete cage, dead from exposure after being locked out of its shelter on a freezing night. 88 years later, we're still haunted by grainy footage of this creature pacing behind bars, still mesmerized by those impossible jaws that could open at 20 degrees, still heartbroken by the realization that we watched this animal go extinct and did nothing to stop it. This isn't a story about ancient fossils or creatures that vanished millions of years ago. This is about an animal that your great-grandparents could have seen alive, an animal we photographed, filmed and studied. An animal we deliberately hunted to extinction because we were convinced it was our enemy. This is the complete story of the thylacine, the Tasmanian tiger, and how humanity's fear turned one of Earth's most remarkable predators into a memory. Let's start with what made this creature so extraordinary. The Tasmanian tiger wasn't a tiger at all. It wasn't even remotely related to big cats. It was a marsupial, like kangaroos and koalas, carrying its young in a pouch. But evolution had carved this animal into something that looked remarkably like a wolf crossed with a hyena, painted with tiger stripes. This is what scientists call convergent evolution, when completely unrelated species develop similar features because they fill similar roles in their ecosystems. The thylacine evolved in isolation on Australia and Tasmania, developing into the apex predator of these islands over millions of years. It stood about 2 feet tall at the shoulder. It measured up to 6 feet from nose to tail. Males weighed between 40 and 70 pounds, with females slightly smaller. But these measurements don't capture what made the thylacine truly remarkable. The body was built like a greyhound's, long and lean, with powerful hindquarters designed for sustained pursuit. The coat was sandy brown to grey, marked with 13 to 21 distinctive dark stripes running across the back from shoulders to tail base. These stripes gave the animal its tiger nickname, though they served a completely different purpose than a big cat's camouflage. The stripes likely helped break up the animal's outline in the dappled light of Tasmania's forests, making it harder for prey to gauge distance and movement. The tail was thick at the base, tapering to a point, stiff and unable to wag like a dog's tail. When the thylacine moved, this tail served as a counterbalance, helping the animal make sharp turns during pursuit. The head was where things got really interesting. Large, almost out of proportion to the body, a long snout housing powerful jaws. And here's where the thylacine left every other predator in the dust. Those jaws could open to 20 degrees. To put that in perspective, lions can open their jaws to about 65 degrees, alligators reach about 80 degrees. The thylacine could unhinge its jaws wider than almost any other mammalian predator in history. When it opened its mouth, it looked like a snake, like the face was splitting in half. Early European settlers who saw this in person described it as terrifying, unnatural, like something from a nightmare. But this wasn't just for show. This massive gape allowed the thylacine to deliver devastating bites to prey much larger than itself. It could clamp down on the skull or spine of a wallaby or wombat with crushing force, often killing with a single bite. The jaw muscles were incredibly powerful, anchored to pronounced sagittal crests on the skull. When scientists examined thylacine skulls, they found attachment points for muscles that would have generated bite forces comparable to much larger predators. The teeth told another story about how this animal hunted. 46 teeth total, more than most carnivorous mammals. The canines were relatively short compared to true cats, but incredibly sharp and slightly curved. These weren't designed for the suffocating throat bites that big cats use. These were designed for puncturing and tearing the core, for inflicting massive trauma quickly. The molars were blade-like, perfect for shearing through flesh and crushing bone. When you look at a thylacine skull, you're looking at a killing machine refined over millions of years. But here's what made the thylacine's hunting strategy unique among marsupials. It was primarily a pursuit predator, not an ambush hunter. Most marsupial carnivores are either small opportunistic hunters or, like the Tasmanian devil, scavengers that occasionally hunt. The thylacine was built for the chase. Those long legs could carry it for miles. Eyewitness accounts from the 1800s and early 1900s describe thylacines running down prey with relentless determination, maintaining a steady lope for extended periods. The thylacine would track prey by scent and sight, then begin a pursuit that could last for hours. Unlike a cheetah's explosive sprint or a wolf's coordinated pack hunt, the thylacine employed a strategy of exhaustion. It would follow prey at a sustainable pace, never quite catching up but never falling behind, waiting for the wallaby or kangaroo to tire. When the prey finally stumbled or slowed, the thylacine would close the distance and deliver that devastating bite. This hunting method required enormous energy expenditure, which meant the thylacine needed to eat regularly. Estimates suggest it consumed about 3 to 4 pounds of meat daily when active, though it could gorge on larger kills and then fast for several days. The thylacine was primarily nocturnal, though it was occasionally spotted during daylight hours, especially at dawn and dusk. It had large, dark eyes positioned forward on the skull and providing the binocular vision necessary for judging distances during pursuit. The ears were rounded and stood erect, capable of rotating independently to pinpoint sounds. Smell was likely the thylacine's primary hunting sense. The long snout housed a sophisticated olfactory system that could track prey across Tasmania's diverse terrain, from dense forests to open grasslands. When moving through its territory, the thylacine would patrol regular routes, marking territory with scent glands and urine. Males maintained territories of approximately 7 to 10 square miles, overlapping with several female territories. Females had smaller ranges, typically 3 to 5 square miles, centred on denning sites. Now imagine you're in Tasmania in 1830. You're a European settler, recently arrived on this island at the edge of the world. You've cleared land for sheep farming, brought your livestock from England, you've built a small cottage on the frontier. One morning you walk out to check your flock and find 3 sheep dead. Throats torn open, blood everywhere. The wounds are savage, precise. You've never seen anything like this in England. Your neighbours tell you about the tiger, the striped wolf thing that hunts at night. They tell you these creatures are multiplying, becoming bolder, that they'll destroy your livelihood if you don't fight back. The government is offering a bounty, £1 per dead thylacine, a significant sum in 1830. You don't know that thylacines rarely hunt livestock when wild prey is available. You don't know that wild dogs and human hunters are responsible for most sheep deaths. You just know your sheep are dead and something has to pay. This is how the extinction began. But the story actually starts much earlier, millions of years before any humans set foot on Tasmania. The thylacine family, Thylacinidae, first appeared in the fossil record about 23 million years ago during the early Miocene epoch. These early thylacines were small, probably no larger than a modern quoll, living in the forests of Australia when the continent was wetter and more heavily forested than today. Over millions of years, different thylacine species evolved and went extinct. At least a dozen species are known from fossils, ranging from cat-size to larger than the modern thylacine. The largest species, Thylacinus potens, lived about 5 million years ago, and may have weighed up to 90 pounds, making it significantly larger than the Tasmanian tiger we know. These ancient thylacines shared Australia with a spectacular array of megafauna, giant marsupials like Diprotodon, massive kangaroos, and predators like the marsupial lion Thylacoleo. Around 2 million years ago, the thylacine lineage that would become the Tasmanian tiger emerged. This species, Thylacinus cynocephalus, spread across mainland Australia, Tasmania, and even New Guinea. Fossil evidence shows these animals thriving across diverse environments from tropical rainforests to arid grasslands. They were one of Australia's most successful predators, filling the ecological niche that wolves and large cats occupy on other continents. But then something happened. About 3,000 to 4,000 years ago, thylacines vanished from mainland Australia. The exact timing is debated by scientists, but the fossil record clearly shows these animals disappearing from the continent while persisting on Tasmania. What killed them? The most widely accepted theory points to 3 factors arriving at roughly the same time: humans, dingoes, and climate change. Aboriginal Australians had lived on the continent for at least 65,000 years, coexisting with thylacines for tens of thousands of years. But around 4,000 years ago, dingoes arrived with a new wave of human migration from Southeast Asia. These semi-domesticated dogs were faster than thylacines, hunted in packs, and competed for the same prey species. They also hunted thylacines directly, especially young ones. Simultaneously, Australia was experiencing a drying trend with forests giving way to grasslands and deserts. The thylacine, adapted for forest and mixed habitat hunting, struggled in these new open environments. Aboriginal hunting pressure may have increased as well, with thylacines seen as competitors for game. Rock art from northern Australia shows humans hunting thylacines, evidence of this conflict. But here's the crucial point. None of these factors affected Tasmania. Tasmania had separated from mainland Australia about 12,000 years ago when rising sea levels flooded the Bass Strait land bridge. This created an island refuge where thylacines could survive without dingo competition. The Aboriginal Tasmanians, who had also been isolated by the flooding, lived alongside thylacines for thousands of years. Archaeological evidence shows minimal conflict between humans and thylacines during this period. Aboriginal Tasmanians hunted thylacines occasionally but not systematically. Rock art depicts thylacines, suggesting cultural significance beyond mere prey. The two species reached an equilibrium, sharing the island's resources. Then in 1803, the British arrived, and everything changed. The first European settlers in Tasmania described an island teeming with wildlife. Thylacines were common, especially in coastal areas and grasslands. Early accounts describe them as curious but shy, occasionally approaching human settlements at night. They showed little fear of humans initially, never having encountered firearms or systematic hunting. This naivety would prove fatal. As sheep farming expanded across Tasmania in the 1810s and 1820s, conflicts with thylacines increased. Whether thylacines actually killed many sheep remains debatable. Modern analysis suggests wild dogs, feral cats, and human sheep thieves were responsible for most livestock losses. But the thylacine became the scapegoat. Its appearance, especially that nightmare jaw gaping wide, terrified settlers unfamiliar with marsupial predators. Stories spread of thylacines as bloodthirsty killers, slaughtering sheep for sport, attacking humans, even snatching children. None of these stories had credible evidence, but fear doesn't require evidence. In 1830, the Van Diemen's Land Company introduced the first bounty system, paying settlers for dead thylacines. This marked the beginning of systematic extermination. Professional hunters called tigermen emerged, specializing in tracking and killing thylacines. They used traps, scares, and poison, targeting known thylacine territories. The methods were brutal. Leg-hold traps would catch thylacines, leaving them to suffer for hours or days until the hunter arrived to finish them off with a rifle or club. Poison baits, intended for thylacines, killed countless other native animals. Den sites were raided, with young thylacines killed before they could mature. Between 1830 and 1909, the government paid bounties on 284 thylacines. But this number only represents animals officially claimed. Thousands more were killed without bounty claims, shot on sight by farmers, poisoned dead, or trapped and left to die. If you're fascinated by stories of extinct animals and the complex relationship between humans and wildlife, subscribe because we explore these incredible creatures and their stories daily. Understanding what we've lost helps us protect what remains. By the 1850s, naturalists visiting Tasmania noticed thylacines becoming scarce in settled areas. The animals had retreated to remote wilderness regions in the west and southwest, mountainous areas less suitable for sheep farming. But even here they weren't safe. The bounty system incentivized hunters to pursue thylacines into these refuges. By the 1880s, sightings in eastern Tasmania had become rare. The thylacine population was collapsing, fragmented into isolated pockets. In 1888, the Tasmanian government increased the bounty to £1 per animal, a fortune for a working man at the time. This accelerated the slaughter. What makes this even more tragic is that scientists of the era recognized what was happening. In 1901, naturalist Harry Burrell warned that thylacines were facing extinction and urged the government to stop the bounty system. His warnings were ignored. The last known wild thylacine was shot by a farmer named Wilf Batty in 1930 in the Morbana region of northwestern Tasmania. The animal was female, and she left behind a joey in her pouch. The joey survived briefly in captivity before dying, one of the last of its kind. By this point, the species was functionally extinct in the wild. But a handful survived in captivity. And here's where the story becomes even more painful. Zoos in Australia and overseas had displayed thylacines since the 1850s. These animals rarely bred in captivity, and most died within a few years of capture. The longest surviving captive thylacine lived at the Beaumaris Zoo in Hobart, Tasmania. Its name, according to records, was Benjamin, though some researchers question whether the zoo actually named it or if this name was applied later. Benjamin was captured as an adult in 1933 and brought to the zoo in the Florentine Valley. Photographs and film footage of Benjamin show a healthy-looking animal, alert and active despite its captivity. The famous film footage, shot in 1933, shows Benjamin pacing in its enclosure, opening that incredible jaw wide in what might be a yawn or a threat display, and moving with the distinctive stiff-legged gait that characterized thylacines. This footage, lasting barely a minute, is now the most viewed piece of extinct animal documentation in existence. Millions have watched Benjamin pace behind those bars, watched that jaw open, watched one of the last thylacines that would ever exist. But what the film doesn't show is the neglect. Beaumaris Zoo was a private facility, poorly funded and inadequately staffed. The thylacine enclosure was concrete and barren, without shelter or enrichment. The diet was irregular, sometimes going days without proper feeding. The keeper responsible for the thylacine section was often absent or drunk. On the night of September 7, 1936, temperatures in Hobart dropped to near freezing. Benjamin was locked out of its sleeping quarters, likely due to keeper negligence. Thylacines, despite their fierce reputation, were not particularly cold-hardy animals. Their short fur and lean builds made them vulnerable to extreme temperatures. When keepers found Benjamin the next morning, the animal was dead, apparently from exposure. There was no ceremony, no recognition of what had just happened. The zookeepers buried the body somewhere on the grounds. No autopsy was performed, no tissue samples were preserved. The exact burial location was never recorded. The last thylacine simply disappeared into the ground, unmourned and unmarked. The species was officially declared extinct in 1936, though the Tasmanian government didn't protect it until 1938, 2 years too late. The international community recognised the thylacine as extinct in 1982, and it was removed from endangered species lists in 1986. But here's where the story takes a strange turn. People have reported seeing thylacines in Tasmania every year since 1936. Over 4,000 sighting reports have been filed, describing striped carnivores with dog-like faces and stiff tails. Some witnesses seem credible: experienced bushmen, naturalists, even scientists. In 1982, a wildlife ranger named Hans Narding reported watching a thylacine for 3 minutes at close range in the northwest wilderness. His detailed description matched the animal perfectly. In 1995, a thylacine researcher received a plaster cast of a footprint that appeared to match thylacine tracks. Camera traps have been deployed across Tasmania, millions of hours of wildlife footage reviewed. Organised searches have combed remote areas, but no confirmed evidence has ever emerged. No bodies, no fresh tracks verified by experts, no DNA samples, no clear photographs or video. The scientific consensus is clear. If thylacines survived past 1936, they certainly didn't survive long enough to maintain a breeding population into the modern era. Yet the sightings continue. Why? Several explanations exist. Some witnesses likely see Tasmanian pademelons or other native animals under poor lighting conditions, their minds filling in details to match expectations. Some reports may be deliberate hoaxes, but some witnesses genuinely believe they've seen something extraordinary, and their sincerity is undeniable. This speaks to something deeper than misidentification. The thylacine has become Tasmania's ghost, a symbol of loss and guilt. People want it to exist because its survival would mean we didn't completely destroy it, that our crime wasn't final. Every sighting report is a small hope that redemption remains possible, but hope without evidence is just wishful thinking, and the evidence says the thylacine is gone. So what exactly did we lose when Benjamin died in 1936? From a purely biological standpoint, we lost Earth's largest carnivorous marsupial of modern times. We lost millions of years of evolutionary innovation, a predator uniquely adapted to its environment. We lost the only significant apex predator left in Tasmania, creating an ecological gap that remains unfilled today. The absence of thylacines has allowed wallaby and pademelon populations to fluctuate wildly, affecting vegetation patterns and forest dynamics. We lost a piece of Australia's identity, a unique animal found nowhere else on Earth. But the deeper loss is harder to quantify. The thylacine represented a different path evolution could take, marsupials dominating as top predators, successful in a niche that placental mammals fill on every other continent. The thylacine proved that marsupials could be just as effective as wolves or big cats when given the opportunity. Its extinction closed that chapter of evolutionary history permanently. The thylacine also represents our capacity for destruction motivated by fear and economic interest. We killed this animal based on largely unfounded fears about livestock predation. We ignored scientific warnings. We offered bounties that incentivized complete extermination. We let the last one die from neglect in a third-rate zoo. This pattern has repeated throughout human history with countless species, but the thylacine's case is particularly stark because we documented it so thoroughly. We have photographs, we have government bounty records, we have the film of Benjamin. We can see exactly what we destroyed and exactly how we did it. There's no excuse of ignorance, no claim that we didn't know what we were doing. We knew, we just didn't care enough to stop. Now here's where the story takes a turn toward the future. In recent years, scientists have discussed the possibility of bringing the thylacine back through de-extinction technology. The idea isn't as far-fetched as it sounds. In 1999, researchers from the Australian Museum extracted DNA from a thylacine pup preserved in ethanol since 1866. They successfully sequenced portions of the thylacine genome and even inserted some thylacine genes into mouse embryos, proving the DNA was still functional. In 2002, a de-extinction project was launched with the goal of cloning a thylacine using nuclear transfer technology similar to what created Dolly the sheep. The project was cancelled in 2005 due to technical limitations. The preserved DNA was too fragmented, containing too many gaps to create a viable genome. But technology has advanced dramatically since then. In 2017, researchers at the University of Melbourne sequenced a near-complete thylacine genome from a 108-year-old preserved pup. The quality of this sequence was remarkable, containing enough information to theoretically reconstruct most of the thylacine's genetic code. In 2022, Colossal Biosciences, the company also working on woolly mammoth de-extinction, announced a thylacine de-extinction project with $15 million in funding. Their approach involves using CRISPR gene editing to modify the genome of the thylacine's closest living relative, the fat-tailed dunnart, inserting thylacine genes to create a hybrid that would increasingly resemble a thylacine through successive generations. Theoretically, they could produce something that looks and behaves like a thylacine within a decade or two, but should they? The ethical questions surrounding de-extinction are complex and troubling. First, what exactly would they be creating? A true thylacine or a genetically modified dunnart that merely resembles one? The creature would have thylacine DNA but would be gestated and raised by dunnarts or artificial wombs. It would never have thylacine parents to teach it how to be a thylacine. Thylacines were sophisticated hunters with learned behaviours passed from mother to offspring. How do you teach a resurrected animal to be itself when no teachers remain? Second, where would it live? Tasmania's ecosystem has adapted to 88 years without thylacines. Reintroducing an apex predator could destabilise existing food webs, potentially harming species that are currently endangered. The Tasmanian devil, for example, has expanded into ecological niches the thylacine once occupied. Would de-extinct thylacines compete with devils, potentially harming an already struggling species? Third, what's the real motivation? Is de-extinction about conservation and ecological restoration, or is it about easing human guilt? Are we trying to fix a genuine ecological problem, or just make ourselves feel better about what we destroyed? Some conservationists argue that the enormous resources required for de-extinction, potentially hundreds of millions of dollars, would be better spent protecting the thousands of species currently facing extinction. Why resurrect one extinct animal when we could save dozens of living ones with the same investment? Others argue that de-extinction technology development could benefit living species by providing tools for genetic rescue of inbred populations and restoration of lost genetic diversity. The debate continues without clear resolution. But let's talk about what we actually know about thylacines, from the precious few that lived in captivity. Early zoo specimens gave us glimpses of behaviour that would otherwise be lost. Thylacines were described as shy and nervous in captivity, rarely aggressive toward keepers unless cornered. They preferred to sleep during the day, becoming active at dusk. When hunting live prey in enclosures, they would stalk carefully, then rush in a burst of speed, attempting to bite the back of the neck or spine. They could maintain a hopping gait similar to a kangaroo's, bouncing on their hind legs, though they primarily moved on all fours. Vocalizations included a series of husky coughs, described as almost bird-like, along with growls and what witnesses described as a quiet whine. The most distinctive sound was a coughing bark, usually given when disturbed or excited. No recordings of these sounds exist, though several witnesses described them in written accounts. Breeding behaviour in captivity was rarely observed. Thylacines typically gave birth to 2 to 4 joeys after about a month's gestation, incredibly short even for marsupials. The tiny underdeveloped joeys would crawl into the mother's pouch, which opened backward like a wombat's, not forward like a kangaroo's. This backward opening pouch makes sense for a predator that moves through underbrush and dense vegetation, protecting the joeys from branches and thorns. The young would remain in the pouch for about 3 months before emerging to ride on the mother's back. Weaning occurred around 6 months, and sexual maturity was reached at about 2 years. Total lifespan in the wild is unknown, but captive specimens lived up to 13 years, suggesting a potential lifespan of 15 to 20 years in optimal wild conditions. Their diet in the wild was reconstructed from stomach contents of killed animals, scat analysis, and observations of captive feeding. Thylacines primarily ate medium-sized mammals, wallabies, possums, wombats, and pademelons. They also consumed birds, including emus, and likely scavenged when opportunities arose. Contrary to settler claims, there's little evidence they regularly hunted sheep when wild prey was available. Most documented cases of livestock predation occurred in areas where thylacine populations were already decimated and natural prey was scarce. A hungry thylacine would certainly kill a sheep if given no alternative, but this was opportunistic behaviour, not preferred prey selection. One fascinating aspect of thylacine biology that scientists are still debating is their metabolic rate. Some researchers suggest thylacines had lower metabolic rates than similar-sized placental carnivores, allowing them to survive on less food. This would be consistent with other marsupials, which generally have metabolic rates about 70% of equivalent placental mammals. A lower metabolism would explain how thylacines maintained territories in Tasmania's resource-limited environments. It would also explain their hunting strategy of persistence rather than explosive sprints. A low metabolism predator can afford to chase prey for hours because energy expenditure remains manageable. But this also meant thylacines were vulnerable to starvation when prey became scarce, potentially explaining their decline once Europeans began decimating native wildlife populations. The thylacine's closest living relative is the numbat, a small termite-eating marsupial that weighs about a pound. This seems absurd until you understand marsupial evolution. The last common ancestor of thylacines and numbats lived about 40 million years ago, before the diverse radiation of Australian marsupials. From that common ancestor, one lineage became hypercarnivorous pursuit predators, while another became specialized insectivores. The divergence is so extreme that without genetic evidence, you'd never guess the relationship. The next closest relatives are dunnarts and quolls, small to medium carnivorous marsupials that share some thylacine characteristics like carnivorous teeth and hunting behavior. But the evolutionary distance is still vast, tens of millions of years of separate development. This genetic isolation means resurrecting a true thylacine is exponentially harder than resurrecting something like a woolly mammoth, which has living elephant relatives separated by just a few million years of evolution. Every gene edit required to transform a dunnart into a thylacine represents millions of years of evolutionary change. The genome editing would need to be extraordinarily extensive, potentially affecting thousands of genes, and we don't even fully understand what many of those genes do or how they interact. We might create something that looks like a thylacine externally but functions completely differently internally. Or we might create something that simply isn't viable, dying during development because the genetic modifications are incompatible with basic survival. Let's return to Benjamin, pacing in that concrete enclosure in Lot 33. When we watch that footage now, what should we feel? Sadness, certainly, for an animal that deserved better than a cold night and a locked door. Anger, perhaps, at the systematic destruction of an entire species for economic gain. Guilt for the collective failure of humanity to recognize what was being lost until it was too late. But maybe we should also feel something else, determination, a resolve to not let this happen again, because here's the reality. We're currently conducting dozens of smaller-scale versions of the thylacine extinction around the world. The Javan rhino with fewer than 70 individuals left. The vaquita porpoise down to about 10 animals. The northern white rhino, functionally extinct with only 2 females remaining. Each of these species is a thylacine in slow motion, circling the drain while we debate economics and policy. The thylacine story is a warning. It shows how quickly an abundant species can vanish when economic incentives align against it. In 1800, thylacines were common across Tasmania, numbering in the thousands or tens of thousands. By 1930, they were gone from the wild. 130 years from abundance to extinction. That's 3 human generations. Your great-great-grandparents could have seen thousands of thylacines. Your great-grandparents might have seen a few. Your grandparents saw none living free. This can happen to any species if we allow it. It's happening right now to species around the world, in time frames just as compressed. But the thylacine story also offers hope, strange as that sounds. The outpouring of grief and regret following the thylacine's extinction contributed to the global conservation movement. The image of Benjamin pacing behind bars became a symbol of human destructiveness and the urgent need for species protection. Laws were changed, attitudes shifted. Species that might have followed the thylacine into oblivion were instead protected and preserved. The Tasmanian devil, for instance, was hunted extensively in the early 1900s but was protected in 1941, partly because of guilt over the thylacine. The devil now faces a different threat, a contagious facial tumour disease, but conservation efforts are keeping the species alive. Would we be fighting so hard to save devils if we hadn't lost thylacines? Maybe not. Every piece of thylacine material that survives takes on enormous significance now. About 800 thylacine specimens exist in museums worldwide, mostly sins and skeletal remains. A few preserved whole bodies exist, including several young pups preserved in fluid. These specimens are priceless, irreplaceable windows into a vanished species. They're also potentially the source material for de-extinction attempts. DNA extraction from museum specimens is destructive, removing small tissue samples that can never be replaced. Museums face agonizing decisions about whether to allow sampling, potentially destroying part of their collections for the chance, however slim, of bringing the species back. The thylacine has also become embedded in Australian culture in ways that living animals rarely achieve. It appears on the Tasmanian coat of arms, on licence plates, on the logo of Tourism Tasmania. The extinct animal has become more famous than it ever was while alive, a ghost haunting the Australian consciousness. Books, documentaries, artworks, and scientific papers pour out every year, each exploring some aspect of thylacine biology, history, or cultural significance. The creature we destroyed has become immortal in human memory, if nowhere else. Indigenous Australians have their own relationship with the thylacine, one that predates European colonisation by thousands of years. Aboriginal rock art depicts thylacines in various poses and contexts. Some artwork shows hunting scenes, others show thylacines in what might be ceremonial or mythological contexts. The Palawa people of Tasmania have oral traditions about thylacines, stories of coexistence and occasional conflict. These stories are reminders that humans and thylacines shared the landscape successfully for tens of thousands of years before European arrival. The catastrophic decline only happened when attitudes toward wildlife changed, when animals became commodities or competitors rather than fellow inhabitants of the land. If you're still engaged with this story, if you're thinking about what it means for modern conservation efforts and the species we still have a chance to save, subscribe because we explore these critical connections between past extinctions and present conservation challenges every day. Understanding our failures helps us avoid repeating them. Modern Tasmania is ecologically poorer without thylacines. The island's ecosystems are simpler, less dynamic. Wallaby and padmolan populations boom and crash without apex predators to regulate them. Forest understory vegetation is overbrowsed in some areas, completely denuded by herbivores without predation pressure. The Tasmanian devil, a scavenger that occasionally hunts, is the closest thing to an apex predator Tasmania has now, but devils aren't pursuit predators. They don't regulate herbivore populations the way thylacines did. The ecological role thylacines filled remains empty, and the island's ecosystems show the strain. What would happen if we successfully de-extincted thylacines and released them into Tasmania? Initially, chaos. The reintroduced predators would encounter prey species with no anti-predator behaviours evolved for thylacines. Wallabies would be easy targets, potentially leading to local prey population crashes. Thylacines would need to relearn hunting strategies, likely leading to high mortality among the resurrected animals. Many would starve before figuring out how to hunt effectively. Human-wildlife conflicts would emerge as thylacines encountered livestock, vehicles, and human settlements. Public opinion would be divided between celebration and fear. Some farmers would see the return of the sheep killer they had heard stories about from their grandparents. Conservationists would argue about whether resources should go to protecting existing endangered species or supporting the de-extinct newcomers. But over decades, if the reintroduction succeeded, Tasmania's ecosystems might begin to rebalance. Herbivore populations would stabilise under predation pressure, vegetation patterns would shift. The thylacine's ecological role would be filled again. The island would be more complete, more functional. Whether we'd call this restoration or just creating something new is debatable. The Tasmania of 2025 is not the Tasmania of 1800. The ecosystem has changed profoundly. European plants and animals have invaded. Climate patterns have shifted. Indigenous hunting pressure no longer exists. Sheep farms cover land that was once wallaby habitat. Reintroduced thylacines would be entering a fundamentally different world than their ancestors knew. They'd need to adapt to survive, and adaptation takes time, generations, evolutionary pressure. We'd essentially be creating a new species, one that looks like the old thylacine but behaves according to modern Tasmania's ecological rules. Some scientists argue we should focus on preserving what we have rather than resurrecting what we've lost. Tasmania still hosts unique species found nowhere else. The Tasmanian devil needs conservation support as it battles devil facial tumour disease. The 40-spotted pardalote, numbering fewer than 1,000 individuals, is critically endangered. The eastern bettong, extinct on mainland Australia, survives in Tasmania but faces habitat loss. The masked owl subspecies found only in Tasmania is declining. Each of these species could be the next thylacine if we don't act. Spending hundreds of millions on de-extinction while living species go extinct for lack of funding seems perverse, a monument to human guilt rather than genuine conservation. But others argue that de-extinction research drives technological innovation that benefits all conservation efforts. Gene editing tools developed for thylacine resurrection could help save inbred populations of living species by introducing genetic diversity. Artificial reproduction techniques could help species that struggle to breed in captivity. The attention and funding brought by high-profile de-extinction projects might increase overall conservation resources rather than diverting them. The debate is genuine and important, without clear right answers. Both positions come from people who care deeply about conservation and have legitimate concerns about resource allocation and priorities. What would a thylacine think of all this, if it could think in human terms? Would it want to be brought back and to have descendants manufactured in a laboratory and released into a world they don't understand? Or would it prefer to remain extinct, a cautionary tale, rather than become a science experiment? We can't know, obviously. Animals don't consent to de-extinction, but the question highlights the fundamentally human-centered nature of the entire enterprise. We want thylacines back because it would make us feel better, because it would be scientifically exciting, because it would be a triumph of technology. The actual welfare of hypothetical de-extinct animals is secondary to our desires. This doesn't necessarily make de-extinction wrong, but it's worth acknowledging that we're doing it for ourselves, not for the thylacines. The thylacine in captivity displayed behaviours that suggest high intelligence and adaptability. Keepers reported animals learning to anticipate feeding times, recognising individual humans and showing distinct personalities. Some were bold and curious, investigating new objects placed in their enclosures. Others were shy and withdrawn, hiding when humans approached. One keeper at Hobart Zoo described a male thylacine that would regularly test the strength of its enclosure, systematically pushing against different sections of the fence as if looking for weaknesses. Another report describes a female that learned to flip open the latch on her den box by hooking it with a paw and pulling. These accounts suggest cognitive abilities comparable to dogs or wolves, intelligent enough to learn, adapt, and problem solve. In the wild, thylacines likely live solitary or in pairs, coming together primarily for breeding. Some historical accounts describe small family groups, possibly a breeding pair with subadult offspring, hunting cooperatively. But the evidence for cooperative hunting is thin and disputed. Most reliable accounts describe solitary hunters. The thylacine's hunting strategy of persistence pursuit doesn't really benefit from cooperation the way wolfpack hunting does. A single thylacine could run down a wallaby just as effectively as several thylacines working together. In fact, multiple predators might be counterproductive, with prey alerted by the noise and commotion of several pursuers rather than one stealthy tracker. Communication between thylacines remains mysterious. We know they vocalized, but the lack of sound recordings means we can only rely on written descriptions. The coughing bark seemed to be a distance call, allowing individuals to locate each other or warn others away from territory. The husky cough growl was likely a threat display or expression of agitation. The quiet whine might have been a contact call between mates or mothers and offspring. Scent marking was probably the primary communication method, with urine marking at regular points along territorial boundaries and pathways. Thylacines had relatively long legs and likely marked at higher points than smaller marsupials, making their scent marks more prominent. Physical displays also played a role. The famous jaw gape, that terrifying 120-degree opening, was almost certainly a threat display. When a thylacine felt threatened or was challenging another thylacine, it would stop, face the threat, and open its jaws as wide as possible. This display communicated both the animal's formidable weapons and its willingness to use them. Combined with a forward-facing posture and growling vocalizations, this display would have been sufficient to deter most competitors or threats, but it had the opposite effect on frightened settlers, who saw the gaping jaw as confirmation of the thylacine's monstrous nature. The pouch of the female thylacine was unusual among marsupial predators. Most carnivorous marsupials have shallow pouches or no pouch at all. The thylacine had a well-developed pouch that could fully enclose 4 joeys, opening backward like a wombat's. This pouch structure suggests thylacines move through dense vegetation, where a forward-opening pouch could snag on branches. It also suggests the young rode in the pouch longer than typical for carnivorous marsupials, possibly because the mother needed to travel long distances while hunting. A backward-opening pouch is more secure for an active, fast-moving animal. Male thylacines had no pouch but did have a unique anatomical feature, a partial pouch-like fold of skin that partially protected the testes. This is rare among marsupials and its function is unclear. Some researchers suggest it provided protection during movement through dense vegetation. Others think it might have been a vestigial structure, evolutionary remnant from an ancestor with a full pouch in both sexes. The structure is described in anatomical studies but poorly understood because so few specimens were available for detailed examination. The decline and fall of the thylacine happened so quickly that scientific study never really got started before it was too late. The first detailed anatomical study wasn't published until 1904, when the species was already rare. Behavioral studies in captivity were minimal, mostly casual observations by zookeepers rather than systematic research. No one studied thylacine ecology in the wild, documented their hunting success rates, or measured territory sizes properly. All our knowledge of wild thylacine behavior comes from scattered historical accounts, often by farmers and hunters who viewed them as pests rather than subjects worthy of study. We lost the species before science could understand it. This pattern has repeated throughout history and continues today. Species go extinct while still unstudied, their biology unknown, their ecological roles unquantified. The Yangtze river dolphin went extinct in 2006 before scientists could complete basic population studies. The Pinta Island tortoise vanished in 2012 when Lonesome George died, his species barely documented. The Pauli honeycreeper went extinct in 2004 before anyone filmed it or recorded its songs. We're losing species faster than we can study them, each extinction erasing information accumulated over millions of years of evolution. The thylacine was just one example of this larger tragedy. But maybe, paradoxically, the thylacine's fame in death serves a purpose. Its image is instantly recognizable, its story widely known. When we talk about extinction, we can point to the thylacine as a concrete example, not an abstract concept. We have Benjamin's footage to show what extinction looks like, an animal pacing behind bars, oblivious to the fact that it's the last. We have government bounty records proving human culpability, showing that extinction wasn't an accident but a deliberate policy. We have written accounts of the hunting, the killing, the methodical eradication. The evidence of our guilt is overwhelming and undeniable. And maybe that's useful. Maybe having one extinction so thoroughly documented, so impossible to deny or rationalize, helps us face what we're doing to other species. The thylacine also demonstrates how quickly public opinion can shift. In the 1800s, Tasmanians wanted these animals dead, paid bounties to ensure their destruction. By the 1930s, scientists were warning that the species was doomed. By the 1940s, Tasmanians had begun to realise what they'd lost and guilt set in. By the 1960s, the thylacine had become a symbol of Australian natural heritage, something precious that was carelessly destroyed. Today, polls show overwhelming public support for thylacine conservation efforts, with many Tasmanians supporting de-extinction research. The animal went from pest to icon in less than a century. This transformation shows that attitudes toward wildlife can change, that species currently viewed as pests or competitors might be treasured by future generations. But it also shows that this change often comes too late. What lessons does the thylacine teach us about de-extinction ethics? First, that resurrecting extinct species won't undo the harm of extinction. Even if scientists successfully create animals that look and act like thylacines, the original species is still gone. The unbroken lineage stretching back millions of years is broken. The de-extinct version would be something new, not a true continuation. Second, that de-extinction is expensive and complex, potentially diverting resources from protecting living species. Third, that we don't fully understand the ecological consequences of reintroducing extinct species into changed environments. Fourth, that our motivations matter. Are we pursuing de-extinction to fix ecosystems or to assuage guilt? The answer shapes whether de-extinction is genuine conservation or just expensive theatre. But the thylacine also shows that humans are capable of recognising mistakes and changing course. The conservation movement that emerged partly from thylacine guilt has saved countless species. Parks and reserves protect habitats that would otherwise be destroyed. Laws regulate hunting and habitat destruction. Billions of dollars fund conservation efforts worldwide. None of this saves the thylacine, but it saves other species facing similar threats. The thylacine's extinction wasn't completely meaningless if it helped prevent other extinctions. That's cold comfort, but it's something. As we near the end of this story, we should confront an uncomfortable truth. The thylacine isn't special, it wasn't uniquely important or valuable compared to other species. It was just an animal, a carnivorous marsupial that filled an ecological niche. Thousands of other species equally remarkable have gone extinct with far less fanfare. Why do we care so much about the thylacine specifically? Partly because we have footage and photographs, making it real in ways that species known only from bones cannot be. Partly because its extinction is recent and well documented. Partly because it happened on an island, creating a bounded narrative with clear villains and victims. Partly because it looked like familiar animals, wolves and tigers, making it easier for humans to empathise with than something truly alien like a parasitic wasp or deep-sea fish. But maybe we should care equally about all extinctions, not just the photogenic ones with compelling stories. The thylacine deserves our attention and mourning. So does every other species we've driven extinct, from the passenger pigeon to the golden toad to the thousands of unnamed beetles and plants that vanish every year as rainforests burn. Each extinction is a library burning, information lost, possibilities destroyed. The thylacine just happened to burn more publicly than most. In the end, the thylacine story is about consequences. The consequence of fear trumping reason. The consequence of economic incentives encouraging destruction. The consequence of ignoring scientific warnings. The consequence of assuming resources are infinite and species are expendable. We made choices, and those choices had consequences. Benjamin died cold and alone because of decisions made decades earlier by people who never saw a live thylacine and didn't care about their future. Our choices today will have consequences for species we'll never see, extinctions that haven't happened yet, but are already in motion because of what we're doing now. We can honour the thylacine by learning from its extinction, by making different choices, by valuing preservation over short-term gain, or we can repeat the pattern until there's nothing left to preserve. The Tasmanian tiger is gone. The forests of Tasmania will never again echo with its coughing bark. No wallabies will be chased by that relentless pursuit predator. No more joeys will develop in that backward-opening pouch. The evolutionary lineage is finished, but the story isn't entirely over because we're still here, still making choices about wildlife and wilderness. Every species facing extinction is a potential thylacine, a creature balanced on the edge. We can push them over or pull them back. The choice is ours, just as it was in 1830 when the first bounty was offered. We made the wrong choice then. We have opportunities to make better choices now. The thylacine can't be saved, but thousands of other species can be, if we care enough to try. Tomorrow we'll explore another extinction story, one that happened 65 million years ago but still shapes our world today. The last day of the dinosaurs, the asteroid that ended an era, and what the rocks tell us about extinction events that reset Earth's biology. It's a story about catastrophe, survival, and the thin line between existence and oblivion. Thanks for watching. See you in the next one.